we want to see how you obtain cos inverse of x dx, and this is the result. So this is done by integration by part, which tells us that u multiplied by v prime is equal to uv minus integral of u prime multiplied by v. So here we are going to let, here you shall let your u to be equal to cosec inverse of x, and we are going to let our v to be equal to dx. So this is cosec inverse of x, and and our v prime is equal to that. Then you get your u prime, which is given by 1. When you differentiate cosec inverse, you are going to get this result here. For the full study on how to obtain cosec inverse, I have done. You can check in my YouTube channel, and you are going to get the result: x into bracket x squared minus 1. Here, when you integrate v, v prime, we are going to get v. When you integrate dx, the result is x plus constant c. We substitute our result. Integral of our u is cosec inverse of x, and our v prime is dx. This is equal to, our v is x, this is equal to x, and our u is cosec inverse of x. That way. Now note here there is a negative. When you integrate this, there is a negative there. Minus integral of our v, this formula here, v is x, divided by a square root of x squared minus 1 multiplied by x. Everything here is dx. Clearly, you can see that in this part, x and x will cancel, and x and x is going to cancel out. Then we are going to have the following. So we want to see now how we integrate. How are we going to integrate negative? There is a negative there. Dx divided by square root of x squared minus 1. X squared minus 1. So we are going to let our x be equal to cosec of theta. Then you get dx, both sides, dx is equal to cosec of theta multiplied by cot of theta d theta. So this is x theta theta d theta. Now we are going to make use of this identity that which tells us this, that cosec squared theta minus 1 is equal to cot squared of theta. So that is the identity we are going to make use of. So note there that cosec is x, so we can write x squared minus 1 is equal to cot squared theta. You can take square root, meaning that cot theta is equal to square root of x squared minus 1. Note that there is a negative there, minus 1. So we substitute here in this formula. Instead of dx, we are going to write integral of cosec of theta multiplied by cot of theta, then d theta. So this is theta, d theta. Everything here divided by instead of x squared minus 1 is cot theta divided by cot theta. Clearly you can see cot theta is cancelling out. Cot theta will cancel out. Now note that here there is a negative here. This negative and this negative here has become positive. Then the next thing, we want now to get integral of, we are left with cosec of theta d theta. Cosec of theta d theta. Now there is a video tutorial which I have given on how to get the integral of cosec theta d theta. So kindly you can check to get the result, but the result will be negative of natural logarithm modulus of cosec theta multiplying plus cot of theta, then modulus plus constant c. That is theta. So when you integrate cosec theta, this will be the result which you are going to get. The process, of course, it is not in this study. You can check in my other YouTube channel and we are going to obtain your result. Then from there now, we are going to substitute instead of cosec theta, we are going to write, we have let here our cosec theta to be x. So we substitute it with x. This is x plus, instead of cot theta, we are going to substitute it with the square root of x squared minus 1. So this is square root of x squared minus 1. Of course, plus a constant c. So we come back here and substitute. So objective was to get integral of cosec inverse of x dx. That was the objective, which is equal to. So up here we found x multiplied by cosec x multiplied by cosec inverse of x. So here we have minus and this other minus in this integral sign to give us plus. So we will have plus natural logarithm of x plus square root of x squared minus 1 modulus plus constant c. which can be written as x multiplied by cosec inverse of x plus natural logarithm of bracket x then bracket 1 plus square root of 1 minus x power negative 2. You close the bracket, then of course plus constant c. So that is how you get the integral of cos inverse of x. So for more details on other integration of inverse trigonometric function, kindly check on my YouTube channel. I have done all of them and you are going to get them in the simple step method so that you may learn with me in this study. Today's focus was to obtain the integration of cosec inverse of x using these simple steps. If you have not subscribed to this channel, kindly consider to do so that you don't miss a single video which I upload every day. Bye bye, see you in the next video.